For anyone wondering, we will be starting in a couple of minutes. I'm going to let things kind of chill for a moment while everybody sort of gets the stream loaded up, and then we'll get going. Just a reminder, we'll be starting in a couple of minutes, letting people sort of filter in. So just hanging out. And yes, the stream is silent. That's on purpose. Dealing with DMCA stuff is a pain, but also it's kind of cool to be able to listen to your own music while the stream is going. So feel free to throw on some tunes. That way you can enjoy whatever music you want. And we'll be getting started in just a little bit. So hang out for a couple minutes, and then we'll get going. Okay. So let's go ahead and get started. Last time we looked at some basic Nix stuff. I'm gonna go ahead and pop open my editor here. Actually, let me do this. I'll switch out of here. So last time we looked at some basic Nix stuff. We learned about the syntax. We learned about imports. We learned about creating outputs, these derivations where we can create packages. And today I wanted to talk about how we can take all that cool stuff that we've learned, like the basic fundamentals of Nix, the language, and start using this thing called flakes to structure some of our outputs and to interoperate with some other cool tools. Before we do that, I wanted to take a quick second to just kind of recap some of the things that we learned, just in case it's a little fuzzy from last time. I don't blame you. So let's just make a little syntax.nix file over here that we can just recap all the stuff that we learned before. We'll do it pretty quickly. So a Nix file has a single expression. So that could be like a number or a string. Or we can use let_in to create variable bindings. So I can say x equals 4. And then the resulting expression will be whatever follows in. So x in this case. And that'll resolve to 4. If I want to evaluate this, I can say nix eval, tell it to evaluate a file, syntax.nix. Oh, forgot to save. There we go. And we get the result from this expression. So that's 4. We also learned about some other kinds of data, that there are attribute sets, which are like dictionaries or objects if you're familiar with from another language. So I can say x has a property name, and that's going to be world. I can say x.name down here to reference the attribute set x, and then get at the attribute name within. If I evaluate that, I get the result. I think we did a little bit of basic string concatenation, stuff like if I say hello plus x.name. Most of this stuff will be very familiar coming from other languages. Some things are a little bit more quirky, like how it decides to do interpolation in strings. It's more like JavaScript. We have this $curly brace syntax, and inside of here we can put an expression. And then we also learned about some lists. Let's take a look at that really quick. Remember, they are space separated, whereas most languages that I've seen anyway like to use comma separation. Don't forget your semicolons. So like I said, we're just cruising through this pretty quickly. A lot of this is very common knowledge from other languages, but also just to recap a couple quirks from the language, like space separation in lists. Or maybe more important is we learned about functions. So if I have a greet function, each function, remember, takes only one argument. So I can say name, and then we say hello name. And my expression can be greet chat. Okay. We also looked at importing other Nix files, right? Because having one expression is only so useful, and let bindings help a lot, right? You can make variables, but when you need to do a lot more stuff, having it all in one file becomes very cumbersome. It becomes very difficult to find where things are and to work with all of the different parts of your code. So we can separate those into other files. Here we have a file with a greet function, right? So it's a single expression that is an attribute set with a greet attribute that is a function. And we can go ahead and import that. Instead of having greet in here, I can say let, we'll say, we'll call it our library is going to be importing that other file, .nix. I can say lib.greet chat, okay? And so remember, this looks like so. And if I evaluate that, it works just like before. All we've done is move the function to another file. Okay. The last thing we learned was derivations. A derivation is the most fundamental part of like doing real stuff in the Nix language. It's how we actually build a package. And we learned about the derivation function itself. We're not going to touch on that again today because, as I mentioned last time, you don't use it. We don't use the raw derivation function because there's a whole lot of work involved in really building anything with it. Instead, it's far more useful to use all of the tooling built atop that, all of the abstraction layers built atop that come in Nix packages, which is this big package repository that we can import. On our system, we have Nix packages, and we can just say import Nix packages with this special syntax. This refers to our Nix path, which has a whole bunch of useful things in it. Can you make the font slightly larger? Yes, I absolutely can. I forgot to do that. Thank you for reminding me. Is that better? Let me know if I need to make it any bigger. So Nix path over here has a whole bunch of useful things in it. These are all of my system's inputs, these different repositories that contain some Nix code. The normal installation of Nix and NixOS will use something called channels. I mentioned it briefly last time. We're going to be focusing on the newer, more modern versions of Nix stuff. So the version 3 CLI, and we'll be talking about Nix Flakes today. And so these are my inputs here, and these are those different repositories. If I say go look at one of these in etc Nix inputs, and I look at Nix packages, for example, we can see this is a directory with a whole bunch of Nix code. You'll see there's a default.nix and a flake.nix, and there's more Nix files hidden in those folders. So what we can do is import this big whole collection of Nix code using this special syntax. So we import Nix packages. And I mentioned last time that this is useful for playing around and useful in some of the older Nix stuff, but we'll realize very quickly when we talk about flakes, we don't even need this bit because we can refer to Nix packages in a more direct way. However, we're importing that whole collection of packages, and then from that, we're going to access a property called stdenv, or an attribute, sorry, habit. And then that's an attribute set, and inside of there, there's a helpful little function called make derivation, which is an abstraction over that raw derivation function. And it lets us do a bunch of really useful things. It has some concepts that maybe we'll talk about today, but the different phases to your build, right? Sometimes you have to patch some files first, then you need to like configure some things, then you need to build, then you have an install step, a whole bunch of stuff that most packages need when you're trying to build them is baked into make derivation, which is super helpful. And we can build this using the Nix build command. We'll give it a file, and it will go ahead and build. And remember, last time I showed us, if we list out the files, we have this new results file here. That result is this special out variable. We talked about outputs last time. Out is the default one. You can have multiple outputs if you want. That'll result in multiple either files or folders. But the idea is you write to your output. So you can make it a directory if you need to store lots of files in it, or you can just make a file. And so in this case, our derivation is just going to echo the text hello into this output path. And so that creates a file there. If I cat result, you'll see there's the text hello. So we built our package, and it gets linked into our local directory. You see here we have this link where it's result is actually pointing to somewhere in that special Nix store where all of the Nix built packages go. All the packages, all of the derivations, everything that Nix handles is actually always in the Nix store, and there are simply links made everywhere else that need to refer to that. Okay, so that was a very quick recap. Before I continue, since this is live, we do have a chat here. Does anybody have any questions on that recap? Anything from last time that maybe you don't totally get before we move on to Nix Flakes? I'll give it a couple of seconds here for the chat to update. And you know what? While everybody is deciding what they might not get, if they want to say anything, I'm going to grab a drink of water, so I'll be right back. Feel free to add your feedback in the chat. Okay. Well, nothing in the chat, so I will assume everyone is a Nix specialist now, or close enough. And we can go ahead and let's see. We can go ahead and start moving on to Flakes. See, Mike over in chat says, it always makes sense when I'm watching done live. When the stream is over and I try it on my own, it's another story. I get that. It can be a little tough sometimes. It doesn't always go the right way. But hopefully, with enough practice, you get there. It can take a little time. And I'm always happy to field questions and stuff if you have any. So maybe next time you can come back with like, hey, I tried this. It didn't quite work. Or feel free to ask questions over on Mastodon as well. So let's go ahead and do this for, hey, Sophie. So let's go ahead and move on to Nix Flakes from here, because using these ad hoc little files and stuff is helpful, but there's some really cool tech in Nix that lets us construct our packages and determine their inputs and build different kinds of things very easily. So let's see. I still struggle with managing build SD image, installer, update a system. That is a great use case for Flakes, and in addition, some cool stuff like NixOS generators. And if you are okay with more abstraction, I have a project called Snowfall Lib, which handles all of that for you, or most of that anyway. And maybe we'll be able to touch on that today. That would be super cool. So let's start with Flakes here. I'm just going to go ahead and get rid of a couple of files that we don't need anymore. And in this directory, I'm going to go ahead and make a new flake. Okay, so a Nix Flake is, if you're familiar with other language like a package.json or a cargo.toml, it's like the metadata for a project in a lot of ways. It can do some more stuff than that, but that's kind of the idea, is that it's the single entry point for Nix stuff in a project. So I'm going to make a flake.nix file. This is a special name that Nix knows about. And if I open that up, I can create my flake. There are two parts to a flake. Well, there's a couple extra little bits, but the important parts are inputs, which will be some stuff. We'll talk about that in a second. And some outputs, which will be some stuff. And we'll talk about that in a second. Okay. Inputs are the things you need to use in order to construct your outputs, which is a very general way of saying this. But what I mean is, like, if you need some packages to build your stuff, For example, if you want to build some Rust things, you probably need Rust C or Cargo. You're going to need to specify those as your inputs for Nix. And the way that we do this is in here, inputs lets you create an attribute set of different names. The name is arbitrary. I'm calling this one Nix packages because I intend to put the Nix packages repository here. And in that, I can specify a URL. So I can say Nix packages is available from GitHub in NixOS/Nix packages. And then I can even specify, this will pull the main branch. I'm going to specify the, actually, not the release, the NixOS 22.11 branch, so that we have a locked down version of that Nix packages repository. So now with our input specified of like, I have these packages that I need, we can specify our outputs. So outputs is actually a function, right? We have to be able to take our inputs somehow and use them. So here we get our inputs as an argument. Don't be confused here. This is a parameter for our function here. This is just an arbitrary name. So this could be like Flake inputs, however you want to spell it or type it. It's totally arbitrary. Call it stuff for all you wanted. And up here is an attribute of our whole flake. It's just an attribute on this attribute set. Okay, so they're only related in so much as they kind of talk about similar stuff, but the actual inputs here that we get are going to be the real like repository that Nix has pulled down for us or fetched. And there are different kinds of things that you can grab even. It doesn't have to be a repo, it could be a tarball, you could point to GitLab or GitHub or Gitty or anything else. Okay, and so we can take those inputs and then construct our outputs. You'll notice this returns an attribute set. And this attribute set has a formal schema. So there are certain properties, or certain attributes, I should say, that's going to keep happening, that you can list here that Nix knows about and will reference when you try and do things. So let's do the simplest possible thing here. Let's go ahead and take a package from Nix packages and basically export it from our Flake as if it's our package. Okay, so we're going to take a package and say, hey, Nix, I have this package available for you to use. And the way we do that is using the packages attribute here. We can say, I have some packages. Okay. Inside of here, we can specify packages for different systems. So I can say x86 64 Linux, for example, which is the system that I'm on. We can take a look at different systems over in the REPL. So if I load Nix REPL, and last time, remember, I did this cool little syntax where we loaded in Nix packages, the same way that we imported it over in our Nix code a little bit ago. So this :L will load some Nix file, and then this less than greater than Nix packages thing points directly to the Nix packages directory. So it'll pull in the default Nix packages file. All right. And in here, I can go ahead and look at lib.platforms, which gives me a whole bunch of different things. If I list all of those platforms, we'll see the different combinations. And so one of those is x86 64 Linux. Okay. And then inside of this attribute set, we're a little nested now, but stay with me here. Inside of this attribute set, we can specify all of the packages for this system. Okay, so for example, I want to take the hello package from Nix packages and export it as a part of this Flake. The way that I can do that is actually, let me load up the REPL again. I'll load in Nix packages and we'll see on Nix packages, there is a hello program. Okay. I'm going to take that program and specify it here. So I want to have a hello program. Okay, so a hello attribute name. This one's arbitrary, so I could be like my hello, right? It's my version of hello. And the value, the package that I'm going to be giving is going to be from my inputs. I know that, right? I have to use Nix packages. Inputs.nix packages. Then we have to figure out how to refer to Nix packages. Let me try something here. I'm not sure if this will quite work, but it would be super cool if it did. No, okay. That's fine. Why don't I do this then? If I hop over to my config stuff and open up the REPL here, I'll cheat a little bit and load. Actually, sorry, thinking on the fly, always fun. Why don't I do this here? I'll comment out this stuff for a moment so that it'll be valid. And I'm going to hop into the Nix REPL one more time. Instead of using this :L thing, I am going to use :LF. And you might think, what does the F stand for? Well, it stands for flake. So instead of load, we're going to load a flake. And I can, I believe, load the current directory as well. Before that, I'm just going to make sure that I have all of my inputs up to date. So I'll say a Nix Flake update. And that's going to pull all of the inputs for my flake. Because what I'm looking to do here is to explore what's available in my flake input as opposed to when you load it the kind of old-fashioned way. So we'll give this a second. Cool. You'll notice it created a lock file. We'll look at that in a little bit. But for now, I think we're focused on loading this flake. And if I just, that's a lot of stuff. If I look at inputs, which is actually our flake inputs, .nix packages, we can see what's in here. So Nix packages actually gives us a whole bunch of stuff. It gives us these like checks, and it has inputs itself, right? Nix packages is its own separate flake, and all flakes have inputs and outputs. You'll see it also has an outputs property. The part that we're interested in is a thing that is unique to Nix packages called legacy packages. And this is different basically only because Nix packages has a different structure. It's more nested, whereas Nix Flakes, we'll see, have to have this flat package structure. So Nix packages has this legacy packages attribute that looks a little bit like our packages output. And on here, we can specify a system. And then we get access to all of the packages that are in Nix packages. So I can say Nix packages dot hello, for example. That's that same package we saw before. This is how we're going to access it from our flake. In fact, it's this exact line here, this inputs.nix packages, legacy packages, what system these packages are built for, and then the name of the package. Okay, so let's go ahead and do that over here on the left side. Okay, and then over in my terminal on the side, I'm going to do a Nix build, and last time we specified a specific file. This time, we're going to build a specific package from our flake. The way that we do this is by specifying two separate parts, okay? So the first part is the path to the flake. So the flake path goes here. And in our case, that's going to be a dot for the current directory. It could be like a GitHub URL, just like our input is typed out, so GitHub : something. You can specify remote flakes. In our case, the current directory is where our flake is. We follow that with a hash, and I know if you're used to Bash, this will look like a comment. It's not, because there's no space before it. So we type a hash. On the right side is going to be the attribute name that we want to use. And since we're doing Nix build, Nix is going to look at our packages to build because that's the only things it can build. And so we don't have to say like packages.x8664 or linux.hello. Instead, we can just specify the name of our package, myhello. See, it built. We didn't get any errors, but if we run an ls, you'll see that result is here again. And you see it points to this hello, which is super cool. If I go ahead and run result /bin/hello, there we go. It's all working, which is super cool. So we pulled Nix packages down with a specific locked version, mind you. And then we specified some outputs for our Flake to say, hey, I have this package for x86-64 Linux systems called myhello, and here's the package. And we're actually just reusing that Nix packages derivation that's already available. Okay. So we did a whole bunch of things there. Let's take a look at some of the underlying stuff that's happening. So when Nix manages dependencies of a Flake, it goes and looks at your URL here, pulls that down, and creates a flake.lock. And this specifies all of the inputs for your Flake, specifying the version that it pulled, specifying the hash of the contents once it's pulled down. And the idea here is that this Flake is now reproducible. So if you take this Flake over to another system, this whole directory with the lock included, over to another system, and you were to run nix build myhello, you would get the same output from your first system because it's using the exact same inputs. You get the exact same dependencies, thus produce the same output. That's the idea anyway. We can have other inputs as well. We'll look at that in just a little bit. And there are other outputs that we can create as well. And hopefully we'll get to that. You can also specify different packages for different system types, like I mentioned. So if I want to build something for like an ARM system, ARC64 Linux, I can specify packages just as well. I can do the same thing here, remembering that I need to change out this little bit, ARC64, so that I make sure to get the right version from Nix packages. And of course, this will be built on an ARM system, so I can't build it on my system without a little bit of shenanigans, like emulation. And all packages that we specify in here need to be in this attribute set. You can't have nested attribute sets. One useful command when you're working with a Flake is Nix Flake show, which actually displays all of the outputs for a Flake. So we can see here, here's my Flake. It's available at this path, and it has this packages, x86-64 Linux, and myhello. If I were to try and have some like my packages and put myhello in here, we would get an error because this output, these outputs have a strong schema we need to adhere to, okay? And that means you need this structure of packages, system, and then any package you want to be available on your Flake. We can also make things a little bit easier for ourselves by not typing as much. If you're just going to export for a single system like we are, let's use letin to make things a little bit simpler. We know what system we're going to use. So we can go ahead and use this instead. Okay. And just like the our other case, we can go ahead and drop system in here because we know what system we're pulling from. So this results in the same output. Let me clean this up. Results in the same exact output, but now we don't have to type the system a whole bunch. Remembering what we looked at last time, we can also simplify some of this. Instead of having to write the nested attribute sets, we can use packages dot and then a property or an attribute name, every time. And that'll do the same exact thing. There we go. And if maybe we need to reuse Nix packages in the future, spoiler, we will, we can go ahead and extract that to its own variable. So I can say packages is going to be all of the packages from this particular system. And then on that package's attribute set, I can just select what package I want. And again, this works the exact same way as before. All right, this is super cool, and we can build packages. Well, we can take packages from Nix packages and use them here. But what about creating our own? Let's do the same thing we did in our previous examples of, previous example of making our own derivation, just writing out a little text file. So instead of packages hello, I'm going to use the same stuff we did before when we imported Nix packages directly. We did packages.stdenv make derivation. I'm going to do the same thing because we have Nix packages right here, and I can stdenv.make derivation. And remember, that's a function that takes an attribute set. And in here, I can specify the name, for example. So my derivation, let's say. I'll call it my derivation. It needs a little source just so it won't complain. And then our install phase is going to be echoing the text, hello world. Oh, we're very excited today, so we're yelling. And then we're going to write that out to out. So this is the exact same example that we had last time of writing out a text file with the word hello, or in this case, hello world. And all we're going to do that's different is instead of saying Nix build pointing to a file that has this code for packages stdn make derivation, we're going to point it to our Flake output. Just like we did with the previous example of my hello, where we exported that from Nix packages, we point to the directory where our Flake is. We use a hash to then specify the name of the package we want to build. So my derivation. And that's going to pull down all of the dependencies that we need for building this package. And then it's actually going to run it, or run the build anyway. If I do an ls, we see we still have a result. This time it points to my derivation. Okay, and remember, my derivation is just going to be the result of this, which is a file with the text hello world in it. So I'll cat result, and I get hello world. And so we can build our own packages and export them in Flakes so they can be consumed by anyone reproducibly, which is the super cool part. Let's look at a real world example really quick. I'm going to jump over to the Snowfall stuff, and let's take a peek at the Cowsay example here, because I think it's super cool. So in this directory, there's a whole bunch of files, but you'll notice two look very similar. We have a Flake and a Flake lock. Because every Nix Flake is named flake.nix, it's really easy to find and really easy to use. This Flake uses some more inputs than what we had, and it defines its outputs pretty similarly to what we had, except you'll notice it doesn't write packages.this, packages.that, because, well, we can abstract on those things. So let's take a look at what this Flake actually looks like using Nix Flake show to see the structure here, because once we start abstracting some of the code, it can be a little hard to jump right in, which is why Nix Flake show is super useful to see once it pulls all the inputs and stuff, to see what we have available here. So here, there's actually more outputs than just packages, but for now, let's just focus on packages right here, okay? Packages supports different systems, it looks like, for this Flake, so you can build the packages on multiple different architectures, which is super cool. our case is going to be that x86-64 Linux, just like before. And you'll see there are a few different packages. So there's cow to image, and there's cowsay. And then there's also a default, which is cowsay again. Interesting. If I try and build one of these, just like before, I'll open a new terminal here. If I say nix build.hash, right, point to the current directory for where our flake is, and then I want to build the cowsay package, it works just like before, because that's what flakes are, right? It's a strong schema you adhere to, and then everything hopefully just works. We end up with a result directory. You'll see it's on the end there. And it points to the cowsay package in the Nix store. Let's ls result, and you see there's a bin directory, which is very common. There are some other additional patterns that are used in the Nix ecosystem to enable like actual use of packages on systems. So if you think about it, like you have a package that you build and then you want to use it, which normally means you put it in like a bin folder that's in your path. You need to make it available to the system somehow. And so conventions are very similar for built Nix packages. You'll create a bin directory with any binaries that you need available. And when someone installs that, all of the things in the bin folder will be made available. And so that's why we've seen result/bin instead of the output actually just being a result file. Okay, but we have result/bin. If I run result/bin and give it the text hello, result/bin, I was almost right. Where am I? Result/bin/cowsay, give it the text hello. It'll print out a very large Albert Einstein, it looks like, saying the text hello, right? We built our package and now we can run it. And so this is a real world example of a Nix Flake that builds a real package that others can use. And here's where flakes get super cool. You can not just pull the flake down yourself and point to the current directory, you can also specify a flake somewhere else that Nix will go fetch and do the same process to. So instead of nix build cowsay with the current directory being specified, I'm going to point it to where this same code is on GitHub. Okay, so snowfall.org/cowsay. And you see it built it. And I can do the same thing as before. Hello, donkey. And you can fetch from not just GitHub, but also GitLab or Gitty, or point to a tarball somewhere, right? There are a whole bunch of different options. Let's see. So we talked about, nope, I want tmux mode. There we go. So we talked about cowsay using an actual package here and building that. Let me mention a useful little utility here. When you're using flakes like this, like everything we've learned so far is enough information for you to actually start building like simple programs using like Bash or something, creating your own shippable scripts that have their own dependencies available. If you want someone else to use that, they could do this nix build and run locally. Or just like before where we saw nix build.hashcowsay to be replaced by GitHub snowfall.org cowsay, right, where that code is hosted. Instead of doing a build and then run, we can actually just tell Nix to do that. It'll build it and run it. And so just like before, it'll do the same thing. And I'll give it the same argument over here of hello that'll be supplied to our script. And there we have the Grinch. So just to quickly recap the CLI stuff that we've learned, there's Nix Flake show, which shows us all of the outputs for a flake. Okay. There's Nix build, which lets you build an output of a flake, for example. .hashcowsay. You can also point to other places on the internet, so GitHub, Snowfall org cowsay, to build. And then there's also run, which does the build and then executes the binary. So that's a real-world example of using Flakes for packages. Let's talk about some of the other things that we can put on Flakes. Actually, before we do that, I need to cover one more thing. We need to talk a little bit more about make derivation, because it is still a little bit magic. Even though we talked about the raw derivation function last time, there are some more things that make derivation does for us. And the most important one is this concept of build inputs. Okay. Build inputs are packages that are made available during a build. There are also other kinds of inputs we can specify, which are inputs, which are packages that are made available during not just build, but also runtime of our program. So let's look at creating a package, a derivation, where the output is the result of running the hello command. So something like this, where normally we would say like hello, and actually I'm just going to get hello really quick. We'll learn about Nix shell in a moment, don't worry. That's where I was going. So we can say hello, it'll print out hello world, but our package is going to run hello and write it to the output file. So maybe like our output, right? And I can print out that output. Our idea is that we want to create a package where this is the process. We have something we need to run in order to produce our result. And the way that we can do that is with build inputs on make derivation. So build inputs is a list of packages that are made available during build, like I mentioned before. We can do this as simply as saying packages.hello is a build input. And now hello will be made available during our whole build process. Okay, let's do this. Instead of echo hello world down here, we'll say hello. In order to build this, we can do the same thing as before. Nix build, and I'll say my derivation, because that's the name over on the left. And if I look, I now have that derivation and I can cat the result. So that's how we can make packages available during build time. What if you need a package during runtime, right? A lot of programs need to refer to different libraries. They need to refer to different other programs that they can maybe shell out to or execute during their lifetime. Well, we can do the same exact thing for native build inputs, as in inputs that are available on the consumer side, on the runtime side, and will be available on the system that the actual code executes on. So we can do the same thing here. I'm just going to move this over, and instead of writing out some text here, let's do this. I'm going to make a new file. Let's call it script.sh. Okay, let's make sure that is executable. And in here, this is going to be a helpful little bash script. And we're going to run that hello program in here. This is going to be our outputted package, the actual binary, rather. This is going to be what we give to a user. We don't need any build inputs, but we do need some runtime stuff available. And our install phase is going to be copying script.sh to out. Okay. We can copy this because we've specified our source here. This copies the current directory over into the context for our make derivation. And so all of the files in this current directory will be made available to the script that's running in here, which is how we get script sh. So I'm going to go ahead and build this again. And if I cat result, we should see a bash script. And we do. So I'm going to run it. And it executes fine because, of course, again, we've specified runtime inputs this time. So native build inputs are for the runtime side. Build inputs are for the build time side. In fact, native build inputs are technically both. So if you do need something available during build and runtime, this is what you want to use. Let's talk now about this last little piece that Nix does, because it's a good example of some Nix shenanigans happening right before our eyes. This line is this line from our script, but they look different. On the left side, I've specified to use user bin-env bash as my interpreter for this script so that when I execute the script, it's run under bash. However, make derivation has some extra stuff that it does. Remember, I talked about those different phases. One of those phases, I believe, is called the fix-up phase. Let me show this off here by saying don't fix up, and I believe that's the right name of this. Thinking on the fly here. If I run a Nix build. Yes. Okay, so if we tell make derivation to not do any of its special fix-up stuff at the end, we get the same script. And it works the same way. Almost. Make derivation does a lot of extra work to make sure that things run properly, that things work. And the way that it does this is by making sure that everything points to the Nix store, the Nix package for that thing. So what we have here is Nix, or more specifically, make derivation, looking at all of the output files from our script here, from this install phase, and saying, okay, if you're pointing to like some arbitrary bash or something, I'm going to swap that out with a direct reference to this version of bash that we are using. Okay, and it does that with any package that you use. So hello is going to be in this environment using specifically the package that we specified in native build inputs. It won't be using a system one if you have one available. It'll be using whatever we specify directly in this derivation. Okay, and turning off that last stage of the magic that it sprinkles on top takes away our ability to actually, well, use the Nix package directly. So we let it do its fix-up phase. And in doing so, we end up with that big reference directly to bash right up here. And then we can run result. Oh, or not. Hello command not found. Delightful. This is a funny one. Let's see. What am I doing wrong? If anybody can spot it, you let me know. Because this could be propagated build inputs. I could have gotten that wrong. Let's try that one. And then instead of copying the script directly to out, we'll make a directory. And we'll pop it in a bin directory. Or not. This is why we don't do things live. Regardless, you get where I was going with a lot of this. There are some special steps that make derivation takes to do a lot of things for you, which is why using the Nix packages tools directly are very useful. And the reason that this specifically for like bash stuff, I don't have the answer immediately to, is because there are other helpers aside from make derivation. For example, we can run, I'll say it was C compiler just for simplicity's sake. We can run a command to create my derivation. And that command will be the same install script that we had before. Let me just put that back over here. And I'm going to specify, actually, I won't specify anything here. So there are a bunch of different helpers that we can use in Nix packages. All right. We'll get to some of these another time, because I think the most important stuff to start talking about are Nix shells. Because we learned about creating packages in the basic sense. And actually doing that more is cool, but we normally need to do some development first, or test things out first. And so instead of looking at packages for a little bit, we're going to look at something else. So I'm just going to keep this packages attribute set empty. And we will have no packages listed. Okay. Instead, what we're going to start working with are dev shells, which are structured the exact same way. So just like packages, we have a dev shells attribute set that has a property for each system we support. And then that system has its own set of packages. Except these are not packages necessarily. These are special development shells that we're going to create with Nix. And the way that we do that is just like a package, specifying a name, so my shell. And we can say packages.makeShell instead of make derivation, which is a special helper that will create all of the extra stuff we need for like jumping into a bash shell and setting up dependencies and all of this extra stuff, and lets us even add extra code for when the bash prompt is initialized. So make shell takes a few different arguments. Let's use one that we've already seen before, build inputs. And I'll say packages.hello. This gives us a shell where hello is available in our environment. So I'm going to open a brand new terminal over here, and I'm going to try and use the hello program. You'll notice it's not here, although I do get a bunch of helpful outputs saying there's lots of hello programs you could try using. What I'm going to do is use Nix shell instead of Nix build, right? Nix build is for packages, and we can use Nix shell for dev shells. And so just like for our package, I can point to where my flake is, current directory, a hash, and then tell it the shell I want to use, my shell. Oh, does it not? Let's see here. Oh, sorry. I'm so sorry. Not Nix shell. Backwards. I wanted Nix develop, which is for dev shells. That's why it's called dev shells specifically. So Nix develop and then .hash and my shell. You can see where the confusion came from. So entering a development shell with Nix develop, I can get a bash session here with all of the inputs that I've specified. So really quick, I'll exit out of there. I don't have hello. I'm going to say nix develop my shell. And now I have whatever programs I need to work on whatever I'm doing. And so you can throw a whole bunch of different things in here. Like if you want, say, Rust C, right? Do I want the Rust compiler? Do I want cargo in here? Do I want Node.js? There's a whole bunch of stuff that you can grab, put into this shell environment, and quickly activate by saying nix develop. We've seen a couple commands now that use this pattern of point to your flake and hash and then like a name. There's actually a shorthand for a lot of this. If you have a common package, a common shell, a common thing that you use for these commands, if you name it default, Nix will use that one, surprise, by default. So if I say nix develop without specifying where my flake is, what the name of the attribute is that I want to use, it will default to .hash default. So I don't have to type that, it will do it for me. And that's how we can get development shells. Nix Flakes have a couple of other things available on them. Right now, I won't really go into depth on them, but we have other kinds of outputs beyond packages and dev shells. There are also a concept of overlays, which you'll notice aren't system specific. There are also NixOS configurations. Ooh. And then some other projects might specify their own things on here that can be made available. So you might find some non-standard ones, like maybe there's a Darwin configurations that another project uses. In the formal schema, though, we also have some other things of checks, which are little programs you can run that if they fail, then your flake, well, is invalid. So a way to basically lint things or run tests or that kind of stuff, just to verify that everything's okay. Let's see. Is there anyone in chat who remembers another output that I'm forgetting here? Any useful outputs that are officially in the schema? If you're curious, you can find that schema over on the NixOS wiki. There it is. I'll drop it in chat. So that'll be listed under Flake schema, and here's actually probably a better link, a more direct one, directly to this schema. And you can see for both the inputs and the outputs, specifies everything. Ah, there are a few others, right. I was forgetting about apps, which are like packages, but specify directly an executable file to run instead of a package, which can be a directory of a lot of things. There's also, this one is not my favorite, but there is a way to specify a formatter for Nix files. There are, NixOS modules. You can create templates using Flakes. We'll look at that in just a moment, I think, for when we're going to get into some more advanced Flake stuff. And then there are a few others that you probably won't use, at least not today, of Hydra jobs, which is a CI system, or legacy packages, which I mentioned is a construct kind of made for Nix packages that you won't be using in your stuff. But whenever you talk about Nix packages, you'll need legacy packages. So That's the outputs structure. These are the things that Nix knows about. Oh, expected a derivation. There we go. So these are the things that Nix knows about. And if you try to put something else here, it will tell you, I don't know what this thing is. Let's see, there we go. I have no idea what lib is, for example, Nix will say. So there are plenty of things that like are in this schema that Nix will know about and will check for you and validate. But there are some things it doesn't know about. And you can always check your flake. If you run Nix Flake show, it will error when it tries to show something invalid. Or you can say Nix, actually, I believe, just check, no, Nix Flake check. Yeah, Nix Flake check, which will perform those checks that you specified, as well as Nix actually looking at your flake and saying, hey, is everything good here? Does it match up to the actual schema of things? So let's start thinking about doing some more useful things with flakes. Specifying one system is useful for you on your maybe one machine. If you have multiple machines with different architectures, that becomes challenging because now you have to like duplicate all of your code. Instead, what if we could maybe not do that? If I want to support multiple systems, for example, like ARC64 Linux as well, right? If I wanted to support ARM systems, I need some way to create outputs that are for each system. And so we could write this ourselves, doing some, maybe we have like functions on each thing here, or maybe we have some helper for creating outputs and merging them together. Basically the idea being to end up with this output, but just multiple systems here. Right, we don't want to have to type all of this because there's a lot of systems you might want to support. So you could go implement everything yourself, or like most people, you could make use of some helpers. So there's an awesome repository called Flake utils. So I'm just going to add an input because I want to pull that in. And I can point to GitHub, and let me just get the link for it. I'll paste it in chat in case anyone's curious and wants to use it on their own. So it's going to be numtide flake utils. And then our inputs will now have flake utils in it. Okay. So let's go ahead, just like before, I'm going to comment all this out here. We'll jump into the REPL. And I'm going to load my flake. Oh, right, I forgot. This is why I updated my lock the last time. When you change your inputs and try to use the REPL, it goes, hey, there's a mismatch from your lock file. You need to make sure to update your lock file. So I'm going to do that by saying Nix Flake update. And that updates all of my inputs. Since Flake utils is the only new or changed one, that's what it prints out here. But if Nix packages had a new version available, that would be updated as well. So now I can go into the REPL, load my flake, and see inputs.flakeutils, see what it has available. Inside of here, there are most of the same things we saw with Nix packages, right? There's a lot of common stuff. The one that we care about for Flake utils is this lib attribute, which is non-standard, right? We just saw that lib isn't something that Nix knows about, but you can put whatever you want on the output of a flake. So Flake utils has this lib attribute that we can make use of, and it's an attribute set of some helper functions. And we can use this to more easily create the outputs of our flake because, well, some other people have gone through the hard work of making a function that lets us specify outputs per system and then merges them all together. So what we're going to be looking at are a few things. So we have these default systems, which are the common ones that are supported on Nix packages. There's also all systems, which actually comes directly from Nix packages, lib, platforms, all, which I showed you a little bit ago. What we're going to be using directly in our flake is actually going to be this helper .lib.each default system. This is a function that, if I go take a look at it, takes in, this is the abstracted version, each default system is using this each system helper with those default systems we looked at. So there will be 4 different architectures supported, 4 different platforms. And it uses this each system helper, which takes those systems and a function, and then by calling that function with each system, you can create all of the individual outputs. And so there's a whole bunch of, well, code to make that happen. And it can be a little bit complex, but we'll see very quickly that it's actually not too bad for us. So just remember that in order for us to do things normally, we'd have to do this packages, platform, or system, and then an attribute set. In the case of using Flake utils, I can just say inputs.flakeutils.lib.each default system, and I'm going to give it a function that will produce my outputs. And I can do that in line here using parentheses to put the function in. Otherwise, Nix gets a little confused with how the syntax works. Okay, I'm going to delete this part. In here, we take a system as our argument, and the output is the output for this particular system. So the way that Flake utils lets you do some things is instead of saying packages.system.blah blah blah, we can say packages directly, and this will get merged according to how that underlying schema needs to work. Flake utils would do all the hard work for us. So I can, just like before, say hello is equal to the hello derivation, and we can get that from Nix packages by saying inputs.nix packages, remember that all of this again, system, and then hello. So I should now be able to Nix build hello, just like before. There we go. And so if I say Nix Flake show, we'll see that we don't just support x86 64 Linux like before. We now support all 4 of those default systems. Super cool, right? If I wanted to support more systems, instead of using each default system, I can say each system and specify my list of supported systems. Let's do this. I want to support only x86 64 Linux, and I want to support x86 64 Darwin, so Mac OS. If I say Nix Flake show, x86 64 Darwin, I missed an underscore. Let's try this again. And you see, Flake utils does the hard work of actually merging all of these different outputs for these different systems to create the same thing that we were originally typing manually. Okay. If I want to support all systems, which you don't normally, but if I wanted to, I could go ahead and say all systems. I think that's the one. Yeah, there we go. And so we could create a flake that supports all systems. The only problem being your packages have to be, well, built for that system. And in our case, we're trying to pull a package of that system from Nix packages, and Nix packages doesn't have a support for that system, so we can't do that. But here's how you could specify more systems very easily to support things. So instead of having to type out the system manually each time for your packages, we can use this each system helper or our each default system helper to quickly construct our Flake outputs. This works the same for all of the other things that we were doing before. So like dev shells, for example, where we were previously creating a shell. Let me pull out Nix packages into a variable here so we don't have to keep retyping it. Just like before, we're taking Nix packages from our input, getting that legacy packages attribute, and then selecting the system, right, from this system that's supplied to our function by our helper. And now in here, we can just say packages. And remember, I can make a default shell, so I don't have to specify things later. I can say packages.makeShell. You'll see that my shells show up not just for my current system, but for every system. And I can say Nix develop. And I'll have that program available. Going another step further, what if I want to use my own package in my dev shell, which is not uncommon? What we can go ahead and do is either extract this out to say like, my package is something, or we can make this attribute set recursive, which isn't something that I mentioned when we were talking about syntax because it's not necessary most of the time and can confuse some things, but in some situations it can be useful. In this case, it is useful because we want to refer to packages.hello from within this same attribute set. So we can do that by adding rec before this open curly brace here for our attribute set. And now any name we type in here, any identifier, can refer to an attribute on that attribute set. So we can refer to packages, we can refer to dev shells. In here, I'm going to say packages.hello. Running develop, it works the exact same way. So we can refer to our package directly from within this. And this is a Nix construct. This doesn't have anything special to do with Flake utils. This is purely just Nix. So we're basically, it would be the same as saying, like, my package is packages.hello, and then specifying this here, as well as here. And this is why I mentioned that rec isn't necessarily required or even useful a lot of the time, because more often than not, you can make a variable instead, and it'll be more clear what's happening. But sometimes, and often for Flake outputs, it can be very easy to get at the things that you need with rec being placed here specifically. So this is how you would do it with Flake utils. There's also some more abstraction that everybody's built on top of Flake utils. One of those projects being something called Flake Utils Plus, which actually does some more of the heavy lifting for us because there's some other things you can do with Nix packages that can still be cumbersome. Nix packages has some very cool things built into it with the ability to modify packages that it is building, that it's giving you. And it uses the system of overlays. We won't go into overlays today because they're a little bit more involved. and it would be easier to show them off with some other tech that we haven't talked about. But we can still appreciate Flake Utils Plus for solving some of these other things. So here's what I'm going to do. I'm going to comment out this code for now. I'm just going to add a little blank attribute set here so Nix stops yelling at me. And we'll compare this code to the equivalent of Flake Utils Plus, which is an abstraction on top of Flake Utils, so that we don't have to write this function call, pretty much. So we can import that just like normal by specifying an input. And I'm going to go ahead and get the URL for this one. Paste it in chat here in case anyone's curious. So that's on GitHub at this URL, I know. But we can use it just like Flake Utils. And the way that we use it is Flake Utils Plus. And we're going to get at a lib property just like before. Actually, before we type it out, let's look at it in the REPL, because that's a good habit to have of and stop recording over there. It's a good habit to have to like explore some of the Nix stuff in the REPL, as it's very useful to like discover things and learn about things. So I'm going to say Nix Flake update because we changed our inputs. And then we're going to say Nix REPL, and we'll load the current directories Flake. And in here are inputs Flake Utils Plus. We can see there's a handful of things in here. We're going to be using the lib just like we did for Flake Utils. And there are similar functions in here to Flake Utils. You're not seeing things. In fact, if I look at flakeutils.lib, you'll notice much of those functions are actually from Flake Utils itself, and they're just passed through Flake Utils Plus. From Flake Utils Plus, we're going to be looking at this make flake helper, because this is what we use to construct our flake outputs. Like how we were using this each default system from Flake Utils to construct our flake outputs, we're going to use make flake from Flake Utils Plus. And to create our flake, we have to do two things. We have to give Flake Utils Plus 2 arguments, because it needs to know about our inputs and it needs to know about our flake itself in order to actually be able to do its job. Because I mentioned it does some cool things under the hood. And so the way that we can do that is, instead of taking this inputs argument just as is, we actually need one thing that's inside of it separate. Or actually, I suppose this is fine. Well, we can keep it as inputs here, because we need to give it 2 things. We need to give it inputs. That's easy. We also need to give it our flake. So how do we give it our flake? Well, our outputs function takes our inputs, right? These inputs, if I just expand this out as if we were destructuring it, are Nix packages, Flake Utils. Actually, I'll delete that one for our sake, so I don't have to type it. And then Flake Utils Plus, right? That's everything, supposedly. If I, let's see here. Let me just comment some of this out and have a little dummy value. if I try and Nix Flake show, Nix Flake update first to get rid of the first warning so that we can focus on this warning, or rather error. When we talked about functions and how they work and destructuring, I mentioned that when you destructure here, you have to specify all of the attributes that will be passed. And if a different attribute is used, that will be an error. If we want to allow more attributes, we can use ... In our case, we didn't. This error is telling us our function is being given another attribute that we're not consuming. And it's called self. So our outputs function takes each of our inputs, Nix packages and Flake utils plus in this case, as well as this self input. Self refers to our Flake itself. It's a little wild if you haven't been working with Nix for a little bit, or maybe some other functional languages that can do this lazy, like recursive evaluation. But self actually refers to our Flake outputs and our Flake metadata as well. So there's some useful stuff on here. And this is part of the reason that we need to give this value to Flake utils plus. So I'll uncomment some of this. And we can give it our inputs. So let's say Nix packages Flake utils plus. And can we format? Nope. Multiple lines, please. Thank you. And then we also need to give it self. Let's try this. Inputs is undefined. There we go. Let's try this. There we go. So now Flake utils plus is going to generate our Flake output. Okay, because we gave it our inputs for our Flake, and we gave it our Flake outputs, which again is super cool. I went and wrote all of this out manually so you could see how it worked, but we can simplify a lot of this thanks to Nix's syntax. So for example, I can say inherit self. Let me put this down here so you can compare it. Inherit self is the same as saying self equals self. Instead of inputs equals, well, the stuff from this attribute set, I can get this whole attribute set named, like I can bind it to a name using this @ syntax. So inputs @, and we can do the same thing here of saying inherit inputs, which again, that's the same as saying inputs equals inputs. Much easier. And since we have two inherits right here, let's just put them together. Say take both of these, okay? And this works just the same. We get some output. So Flake utils plus is generating our output now. And the way that we get to work with Flake utils plus is instead of calling a function directly and, you know, grabbing the packages directly from our inputs and stuff, Flake utils plus will let us specify a function that we can use to manually put stuff on our Flake output, and it will give us package sets for each system. So it makes it a lot easier to actually work with. So for example, I can say, I believe it's outputs builder. That is going to be a function that takes this thing called channels and will return an attribute set. Okay, so nothing changed here because we're not actually doing anything. But on this attribute set, I can specify my outputs just like we did down here. I'm going to do the same thing, specifying packages with a hello package. Now the question is, where do we get our packages from? And the answer is this channels attribute. Channels has our Nix packages channels. This is a concept from Flake utils plus, where if we were to have multiple Nix packages versions, so maybe I'm looking at unstable, for example, and I need some packages from there, channels is an attribute set with both of those. And this is why it needs our inputs, because FlakeUtils Plus will look at your inputs, find the ones that are Nix packages, and make those available in this channels argument. Okay. So in here, I can say channels.nixpackages.hello. And of course, I updated my inputs, and so we're going to end up getting unstable downloaded and that stuff. But we're not actually using a package from there, so it's only downloading the Nix repository. Oop, let's see here. Called with unexpected argument unstable. That's right, because we have a new argument for our inputs here. And there we go. Now we see our packages generated for the most common platforms. This is the default for FlakeUtils Plus. We can customize this just like we did the each system helper from FlakeUtils, but we won't do that today. You can go take a look at the FlakeUtils project, FlakeUtils Plus project on GitHub if you want to learn a little bit more about how to configure it. And so it works pretty much the same way. And you can generate a lot of things. And there's still a few helpers on the library to actually do a few things a little bit easier. So we went from this down to this, right? You can kind of see where this is going, of like simplifying a lot of the code that we need to write to create these flakes, because we understand how useful they are to be able to generate or, well, create and then share reproducible packages or development environments or other scripts or things that have dependencies included. It's very useful. So what I'm going to go ahead and do here is clean up a little bit, and instead of handling this Flake Nix creation manually, what I'm going to do is show you how we can use templates, Nix templates, to start new flakes very quickly, because we understand now how to write a flake. And so the interesting part isn't really writing the boilerplate, it's writing the rest of it. So what I'm going to go ahead and do in here is delete my Flake Nix, my Flake lock, and anything else in this directory so we can start over fresh again. And I'm going to say Nix Flake init, because we started working on flakes manually. So I wanted to cover everything from the very beginning. Nix has built-in support for getting up and running with a flake very quickly with this Nix Flake init command. I just say Nix Flake init, and we end up with a flake.nix. And you'll see this is actually that basic flake that we looked at before, where we just specify our outputs directly and all manually. And so this can be very useful if you just have a simple case of where, you know, you have one system you want to support. I just need something to go. Cool. And I can do the rest myself. If you want to get a little more advanced, we have other templates that we can use. I'm going to use a helper tool that I made called, well, it's a command named Flake. This isn't part of Nix itself. This is a tool that I created to make it a little easier to work with flakes. One of the commands is init, which mirrors that Nix Flake init. And I have a little picker that will look through all of the flakes that I have available on my system and show me the templates for all of those. And just, it can take a little bit because I have some flakes that take a little while to evaluate, but this will give us a visual representation of all of the different templates that my system has available. And these are actually just from GitHub. Most of them are. And you can use any of these to get started. So there are a bunch that are included in the NixOS organization. You can see there's one for Bash and C and Golang, right? If you work with Rust, you can use that. Or the basic one that we just saw is also called Trivial. It's also the default. There are some others that are provided by other people, like FlakeUtils has one for using FlakeUtils. If I wanted to get set up with that each system thing, I just hit each system, and we have basically that same code we wrote just a little bit ago. And this would be equivalent to running the following. Nix Flake init -t for template, or you could spell it out with --template, and then point it to a flake. Just like we were using flakes for build and develop, we can say github numtide flake utils, and then tell it which template we want to use. In fact, one thing I haven't showed off yet is the Nix command line's ability to do autocomplete, or, well, help you. If I hit tab here, it should... Okay, that was a bad example. It doesn't work for templates, but I can do this the same way. And we end up with this template being pulled down and merged here. What I was hoping to show off was the Nix stuff where I hit tab here, and then we end up with all of the possible things that we could use, which is fine if that doesn't work on templates. That's okay. Let's go a little bit beyond Flake Utils Plus right now. I'm going to initialize a new flake using a different template. This is going to be using one of my projects. So just fair warning here, this is not stuff that is included in Nix, right? This is an external project to create a flake. And this is something that I've created. So just fair warning here that you may want to use this, you may not want to use this. But I'm going to create a new flake using Snowfall Lib, okay? And I'm going to show you the cool stuff in a second. I'm going to start with an empty one, and we'll build it out as we go. Mike over in the chat says, I think I'm addicted to NixOS. I still don't know what I'm doing, but I've become obsessed with figuring it out. Totally agree. I started with NixOS probably 14 months ago now, and I felt very much the same way of I don't quite know how to do a lot of things, or I don't totally get how it works, but this is super cool, and I can really see how impactful this is. It's like a 1,000-piece puzzle that has multiple solutions, each unique and challenging. That's not a terrible way of explaining it, yeah. It's not bad. Okay, so I'm going to initialize this new flake using Snowfall Lib. Let's see what we get. And actually, I'm going to take a quick break before explaining this so I can go get some water, and we'll be back in just a moment. Here's a fish tank for your troubles. I'll be right back. Okay. I hope the fish kept you company. Now, let's talk about Snowfall, specifically Snowfall Lib. So we created a new flake that you'll see has a couple of inputs. We have Nix packages, we have unstable, because sometimes you want to pull packages from unstable. We're not going to use that yet. But we also have Snowfall Lib down here. Similar to how we used Flake Utils Plus, we're going to be using Snowfall Lib to construct our Flake output. In fact, Snowfall Lib under the hood uses Flake Utils Plus because there's a lot of really useful things it'll do for us. The difference is instead of specifying packages and shells and all of our things in Nix in our Flake, we're actually just going to put them in the current directory in a specific folder structure. So the way that the way that Snowfall Lib works, let's head over there. Is, if I scroll down, we have a directory structure that Snowfall Lib expects you to follow. And if you do, it will set up all of your Flake outputs for you. Sorry, I clapped my hands together and made a sound. Okay, so we have our Flake file, of course, and then all of the other things like our packages or a library that we want to export or NixOS modules or overlays or systems, NixOS configurations is what those end up as. We just put them in the current directory structured like this. So I'm going to make a package that is going to be that hello package we've just been exporting from Nix packages. The way we do that with Snowfall is instead of writing Nix code in our Flake, I'm going to make a packages directory. Okay, so we have a packages directory. In here, I'm going to put hello / and a default.nix file. Remember, when we looked at Nix imports, we saw briefly, if you import a directory instead of a Nix file, Nix will look for a default.nix in that directory and will import that. So this is that convention being used by Snowfall Lib. In this default Nix, we're going to create a package. Packages specified in Nix packages follow a format of a function that returns you a derivation. Okay, so we have some args, you might call it, or packages is probably a better name. And then our output will be packages.hello, right? Normally, when we're creating packages in Nix packages, it's good to destructure these things so that we only grab what we need and we only evaluate what we really need. So I'm just going to pull out hello directly, and there are some other things in here. So I need to add that ... This will be changing soon. You won't need the ... soon, but for now we do. So I'm just going to pull out hello from this set of packages because that's what we get supplied with. It's all of Nix packages. And then we just give you back hello, the hello package. If I say Nix Flake show, we need, let's call that my hello. Whoops, I wanted to rename that. Let's try again, and I'll name it my hello. There we go, Nix Flake show. And now we get our output of our Flake totally generated by Snowfall Lib, and we didn't have to write any code in our Flake at all. The only code in our Flake is this. It's 4 lines with some space, where we just say, hey, Snowfall Lib, here's my inputs, just like we were doing with Flake Utils Plus. And here's my directory that all my stuff is in. That's all you need to tell Snowfall Lib. And now you get the ability to just drop in packages very quickly. If you're wondering about the error that we just got a little bit ago, we have a package that I had originally named hello. In order to evaluate this, we actually also add in all the packages from your Flake so you can use them in any other package. Since you had one named hello that was using hello and giving you that back, it just kept going around in circles. So changing the name works, or Snowfall Lib has this cool ability to namespace your packages. So it's called overlay package namespace. Currently, this will change to be a more simple namespace name. That's coming in the next few weeks. And so like my packages, I might call it. And now in here, I don't have to worry about that conflicting. I can just say hello is the name of my package. And on my Flake, it'll be named hello. In my attributes here, I will have what did I call it? My packages. I'll have a my packages attribute set here that if I look at the names of, I should see. Print it out. Maybe it'll print it out. Oh, it is. Okay, cool. So here are the traces. One for each system, which makes sense. So our packages are made available. So you get all of the stuff from Nix packages as well as each package from your Flake. So if you have packages in your Flake that each depend on each other, if you need one to build the other, you can do that. You can, by default, nothing will be namespaced and you can refer to them directly. Or ideally, you will namespace things so that you can refer to your packages within your own namespace safely. And when they're exported, they'll be available individually on your Flake or via an overlay, which, again, we're not going to talk about today, but that will forward your namespace so that other people can use your packages namespaced, which is super cool. Okay, so packages, really easy to make. What if we want to create some development shells using Snowfall Lib? We do it the same way as packages, where we can say shells. This is the only time we deviate from the names that are used in that schema. Normally it would be dev shells, but shells is too nice of a name to pass up. And I can say my shell, for example, default.nix. And just like we were doing in our Flake manually, we can create a shell using Nix packages. And this is formatted the same way as our package just was. So we get packages passed in. We'll take make shell from there and hello. In fact, why don't we, this is a good chance to use our namespace. So my packages. We'll say make shell. And our build inputs will contain my packages.hello. And let's look at that first. So we see we now have some shells, right? We have shells for each system. And I can say nix develop, and I'll tell it to use my shell. And we have all of our stuff available. And you'll notice we pulled hello from our Flake. This is actually directly from our package hello, right down here. So this is what I was talking about with pulling packages from your Flake to use. You can do that very easily with this namespace feature or even without it. The only thing is without it, you have to be careful not to conflict with any inputs you might actually need. And this also works for some other things like NixOS systems, and Snowfall Lib specifically has some very cool functionality around supporting different targets. This is backed by NixOS generators and Nix Darwin, which are amazing projects. We won't talk about them today as I think we're just about wrapping up, But next time, I really want to look at systems and how we can handle this in using Snowfall Lib, because just like our packages and shells, all we have to do is create this folder structure, drop in a Nix file, and it's all done for us. Including things like NixOS modules we can create just the same way, and those will be automatically included in the systems we specify. So next time, look forward to that. And if I can make it happen, I would really love to walk through installing NixOS using this flake that we're actually working on here, where we would specify our systems, our modules, and then we can build an installer image with that, build our own custom image, and then we can actually put it we can use that to install NixOS on another system and then customize it. Mike says, I cloned your dot files and was able to get them up and running on a VM. At first, it wouldn't work with my own custom host, but then I realized you had your flake.nix pointing to your Jasper host, which I think is utilizing Snowfall.org. Yeah, so Mike, if we... I'll go ahead and answer that question. And if anybody else has other questions, feel free to ask, because I think we're kind of towards the end of what I wanted to talk about today. And I'll give it a couple minutes for some questions. So my flake is actually doing the exact same thing. There's just lots of inputs because I pull a lot of things. But we still do that make flake from Snowfall Lib. It's just doing a little more fancy things. And then we have systems. So let's always start by doing a little Nix Flake show to look at what's here. There's a lot of things in my flake, but we can scroll up to systems. That's what we were wanting to look at. So NixOS configurations, here we are. So there are a couple different configurations that I have. These are one for each of my systems. And so my system names, I like to follow a theme for all of my devices, that they're all different like gemstones or things. You know, fun to have a theme, why not? And so they're all named things that make sense to me. For example, Bismuth is my desktop, Jasper is my laptop, Quartz is my NAS, Ruby is actually the computer that we'll be installing NixOS on, so I haven't been using it too much yet, so it's a great candidate for installing. It's just another computer that I would be using as a server. Row 138 in my flake. Let's see, then I realized you had your flake.nix pointing to your Jasper host. Are you asking what this does? What this configuration does for Snowfall Lib? I'll give it a second for Mike to respond here. Snowfall Lib lets us do some things when we say make flake. You'll see there's the package namespace stuff that I'm using the dev version, so the name's a little different. Okay, cool. So there's some configuration you can do when you're making the flake itself, because sometimes you want to do a little extra config, customize some things. And so Snowfall Lib lets you specify when you call make flake, you can say set up a namespace, you can configure Nix packages to allow unfree stuff, for example. You can specify overlays. You can add NixOS modules to every system, or you can add modules to specific systems. And so the reason that I am only adding this module to this system is that this machine here is my framework laptop, and there is an awesome project called NixOS Hardware, which contains a bunch of NixOS modules for different machines. And so they're like presets for that CPU and GPU, and sets up stuff like battery and things to be better. And so what I'm doing here is including a NixOS module for the framework laptop that'll configure all of that stuff for me. So I don't have to do it, and I'm only including it on my laptop. And so that's why I'm specifying it here. Cool. We also had a question, do you separate host names from systems? So I'm not totally sure if this will answer your question, but the way that Snowfall Lib works here is we have this systems directory, okay? And you can kind of think of this like the packages structure we saw in our Flake, but for systems, where we have a system, then we have an architecture mixed with a target. And so you'll see this x86-64, right? That's what we saw in packages stuff. But here we have x86-64 Linux, which refers to NixOS. So this will build a NixOS system. Snowfall Lib has other targets where we can also build an ISO image, for example, or an installer ISO that comes with like all of the installer stuff, or build a DigitalOcean droplet image, or an SD card image. And so I think this is one of the questions asked earlier, which we're not going to discuss how to do it today, because next time I think that'll be great, so we can look at all the systems. But this is how you would create an SD card image using Snowfall Lib. Very easily, actually. You do it just like a normal system. And so inside of each of these, so we have systems, then we have host name and target, and then we have the actual, not host name and target, we have platform and target. Inside of here, we have each host name. I was trying to abstract the host names from the physical system. That gets a little bit difficult with how Snowfall Lib works. If you wanted to do something like that, you would need to generate those systems in your Flake. So that would be code that I think you would have to write, unless you want to generate actual configurations here. What you could do for you might be something like, if you have a NixOS configurations, you might have maybe like a number of systems you want to make, or have like 3 of these things, 4 of these things. You would want to map over whatever stuff that is, whether it's like some range of things to create, so that for each system you can customize it. And then you would end up wanting to build your system, and that'll be using Nix packages directly with the inputs Nix packages. Sorry, this is a little bit, it's kind of a lot, I know. I'll try and explain it better in a second. Nix packages lib, and then it's NixOS system, I believe. In here you can specify your configuration, or more specifically your modules. And you can add custom stuff for each one. So I think if you're trying to separate the host name from your systems, and I think the reason that you would be doing that is because you might have like lots of systems that want to use the same config. This might be how you can do that. Or if you're okay with copying some things and just having some basic systems, here's my example of, I have 2 VPSs. Here's the config for one. Here's the config for another. And the way that this works with all of my config is I actually have most of it. You'll notice there's hardly anything going on here. I have most of it broken out into modules. And these modules get added to each system, but they're only adding configuration if they're enabled. And I do that by marking them as enabled. This enable thing is a helper for saying this is the same thing. I just decided I like to type less. So breaking things into modules is very useful, and you can check out my previous video on my system Flake walkthrough to see kind of how I do this, as I go through how I create my systems and how I put in modules and enable things to share configuration between different systems. Unfortunately, if you want the host name to be different, Snowfall Lib doesn't currently do that, so you would kind of be on your own there. But you could use Snowfall Lib for the most part for anything else. Otherwise, you'll have to import things manually. I create one and then copy the directory and rename. That's totally one way you could do it. And admittedly, I only have 2 systems that I'm managing right now, that are so similar, at least, that's kind of what I did, is I made one and was like, well, I need another. Let me just copy paste, I'll make another. It's, I think, manageable for a few. I do think that's a good problem to try and get solved, because eventually I'll get there too, and I'll need to manage a larger fleet of things, and it'd be really cool to do that. And spoiler, I've been thinking about that and considering how I might build a tool for that. But I think currently not exactly how Snowfall Lib will be doing things. So hopefully this was a somewhat useful introduction to Flakes, and maybe gave you some ideas about how you might start trying to build things using Flakes. Maybe you want to start using a dev shell when you're working on a Node.js project, right? You can add a make shell to pull in the version of Node that you need, and now you have a consistent, reproducible development shell to share between developers. Or maybe you want to build your own package and let other people use it, just like Kause. You know, there's a lot of different things that you can do using Flakes. And so hopefully some of you are just as excited as I am about them, and we'll start creating some stuff. So I think that's it for me today. Thank you all for joining me on this adventure. Oh, one last little mention of, I need to figure out how to fix UDev rules for a package I'm building. The UDev rules stuff, I remember I only needed to mess with that once, but I do have a package that does that. I have packaged the UBports installer because I tried installing the Ubuntu Touch on my old OnePlus 3T. And to do that, I also needed to add some UDev rules. And I don't know how UDev rules work. I'm not really a system programmer. I'm a web dev mostly. But figuring it out, there were a set of UDev rules that were specified. Cool. And then I went and looked at Nix packages to see how other programs were using UDev rules. And so that's a really useful thing, is I actually went to the Nix packages search. So if you go to search.nixos.org, and I actually searched UDev and then clicked source on one of those top packages to just see how we were packaging UDev rules. And so it turns out, like I mentioned, there are certain structures that Nix packages will use, and this is defined in the Nix packages manual. It's a long read. I don't blame you if you haven't seen it. But you can put UDev rules in this out lib udev rules.d directory. And if you put them there, then when you install them on your system, they'll be linked and actually used. And so that's should be all you need to do. There was some other stuff of like specifying the name or rather group for these rules. And so it's just swapping out like these rules I copy pasted from the website. And so they say like plug dev. I saw in the other package that they were swapping it out with the name of their package or similar. And so I went and did the same. So hopefully that's maybe all you need to do, is take those rules and then drop them in this directory. And if you want to see this on my config, if you want a link to this file instead of a snapshot, let me go ahead and get that for you. There you go. All right. Well, I think that's it for me. I hope you all have a good rest of your day, and I'll see you next time. I don't have a plan on when the next stream will be. Maybe on a weekend, but it's going to depend how hectic things are and how I'm doing. So if you want to be notified of the next stream, I think probably the best way is like YouTube's notifications, or I'll try and post on Mastodon if I know ahead of time that I'm going to be doing a stream. Sometimes they're sort of guerrilla, sometimes I'll mention beforehand. So hope you all have a good rest of your day, and thanks again. I will see you later.